talking about percentages and simple interest. So we're going to do a quick review of percentages, and then we're going to talk about simple interest. So many people don't like dealing with fractions. Because of that, and because fractions with different denominators are hard to compare the size of. You know, if you want to compare 2/3 and 3/5, that's difficult, right? So we've developed a common standard denominator of 100. So this is to help us compare fractions. We just put them all over 100. And a fraction with a denominator of 100 can be interpreted as a percentage. Percent is the word for Latin word for 100. Per 100. Okay, we use this symbol to indicate the presence of a hidden denominator of a 100. Right, so if you have X%, that means X over 100. Percentages provide a nice way to make comparisons, right? Because we all talk in percentages very frequently, it's easy to compare the size of the fractions because they all have the same denominator. And they provide a useful way of dealing with fees, taxes, tips, and they help us better understand how things increase or decrease relative to some baseline. So for example, suppose that in your English literature class, you scored a 19 out of 25 on the quiz, a 49.2 out of 60 on the midterm, and 124.8 out of 150 on the final exam. What was your best score? The last one? How do you know? You did it? Oh, you changed them all to percentages. Great. So how do you change them to percentages? Yep, so you just divide. So 19 over 25 gives you a decimal. Change it to a percent by moving the decimal 2 spots to the right. So 19 out of 25. There's a couple of different ways you can do it, right? So this first way, we would say we change it to a decimal, right? And then you change that decimal to a percent by multiplying by 100. That's sort of the most common way that people do this. Another way, just for the fun of it, is to change this to a fraction that has a denominator of 100. So what would you multiply the top and bottom by to make the denominator a 100? 4, yeah. So I would multiply this fraction by 4 over 4, which is allowed because 4 over 4 is what? Just a 1, yeah. So I'm just multiplying by a fancy form of 1. 25 times 4 is 100, and 19 times 4 is 76. And 76 over 100 is 76%. Okay, so if I want to convert 49.2 out of 60, divide, and that's an 82. Right? 49.2 out of 60 is 0.82, which is 82%. And then 124.8 divided by 150 is 83.2%. Okay, so this is your best score, the final exam. Nope. No. So the reason I used 4 over 4 is because I had to figure out what I wanted my denominator to go from being a 25 to being a 100. So I multiplied the 25 by 4. And if you multiply the denominator by 4, you're going to do the numerator also. So the reason I didn't do any of the other problems that way is because it's not easy to figure out what you multiply 60 by to make a 100. Or 150. Would you multiply 150 by to make a 100? It's not as easy to do it using that method. Although you can. doesn't come to you as quickly. Okay, so now I want you to talk in your groups regarding this problem. Is 3/20 a reasonable restaurant tip? And calculate a reasonable tip for a meal that's $56.80. Okay, so is 3/20 a reasonable tip? Yeah, what is 3/20 as a percentage? 15%. And this one is an easy one that you can convert using that fraction method. 3/20. I want to make this as something over 100. What should I multiply 3/20 by? 5 over 5. So 20 times 5 is 100, and 3 times 5 is 15. So that's 15%. So that's a reasonable tip. What reasonable somewhere like 15 to 20, right? Okay. So I want to calculate a reasonable tip for a meal that was $56.80. So I'm going to do it without a calculator. So let's say I want to do a 15% tip. No calculators allowed because, well, actually no, in the days of smartphones, everyone has a calculator with them. So I guess it doesn't matter, but you want to impress all your friends by being able to do this in your head, right? So 5680. What's 10% of 5680? 568. Yeah. You just move the decimal one to the left. So if you want to leave a 20% tip, that's really easy because you just take 10% and double it, right? So 568 doubled would be, well, 550 doubled is $11. So $11 to $12 would be oh, 20%, what I'm doing here, would be twice 10%. So it's 1132, 36, 11 to 12. Let's just say $11 to $12 because nobody carries change, right? $11 to $12. All right, and then if you want to leave 15%, and I'm starting with 10%, how do you figure out the remaining 5%? Take half of it, yeah. So you're going to take 568, which is 10%, right? And then add to it half of 568, right? Because if that's 10%, 5% is half of it. So half of 568 would be 250 plus 34, so 284. So that's 852. We'll just say $8 to $9. $8 to $9. So dealing with percentages, we like 10% and just work off 10% because they're easy to do by moving a decimal point. All right, so next example. Imagine you're shopping for a new iPod. You have 3 options of which one to buy. All right, so you can get the iPod from Optimal Buy for $399 plus 675% sales tax. Or you can get it from Hamiltonian Circuits. Tell I wrote this problem a long time ago. First, because of the prices, right? And second, because Circuit City no longer exists. But anyways, Hamiltonian Circuits for $415, and you have a 5% off coupon, and it's 6.75% sales tax. Or you found it from an online merchant in Portland, Oregon. They'll sell you the iPod for $441, including a 5% shipping processing charge, but there's no sales tax in Oregon. But you have a friend from Portland who's planning to visit you anyway, and you could ask her to pick up the iPod for you and save you the shipping charge. So discuss. Figure out which method are you going to use to buy this iPod. Okay, so let's go over these. If you're just going to go down to Optimal Buy, you know, the sort of the easiest thing you could do here is just go to the local Optimal Buy. And you pay $399 plus 6.75% sales tax. So how do we figure out the sales tax? Price times the sales tax as a decimal. right? Or a fraction, because 6.75% means 6.75 over 100, right? That's what percentage means. So you multiply 399 times 0.0675. You got to take your percentage and write it as a decimal, right? Or a fraction. Decimals are just a little easier, right? All right, so that comes out to 26.93. So that is how much tax costs, right? But then you have to add that to the price of the iPod. So my total is going to be $399 plus $26.93. And what's it come out to? $425.93. Okay. So I'm going to show you a little shortcut, right? So if I want to, instead of doing 2 steps here, multiplying by the percent and then adding the price, instead of doing 2 steps where I multiply by the percent and then add the price, I'm just going to do 1 step and increase it by the tax all at once, right? So my total is going to be my original price, $399, times, instead of multiplying by 0.0675, what should I multiply so I can do this in 1 step? Same time, ready? 1, 2, 3. 1.0675. Where'd the 1 come from? Why the heck am I putting a 1? That's the $399. Yeah. The 1 represents 100%, right? We have to pay 100% of $399. You have to pay all of that plus 6.75% more. So the 1 represents the 100%. You have to pay this 100% plus 6.75% more. So 1.0675. And that will give you your 425.93 all in 1 step. Sure, yes, if you have a percent button on your calculator, you can use that also. Yeah, and then you don't have to change it to a decimal. Okay, let's go to next door to Hamiltonian circuits. The price is $415, but we have a 5% off coupon. So let's figure out what the price is if we take 5% off of 415. What do I do? 415 times 0.05, right? That will give me how much I get to deduct. This will give me the sale price. I mean, this will give me the discount. So 5% of 415, 20 what? Okay, I'm getting 2 different answers, so I'm going to do it myself. 0.05 times 415, 20.75. Okay. All right, so that's the discount price. So what's that? I mean, that's the amount of the discount. How much is the price now? So you got that by just subtracting, right? You do the 415 minus the discount of 20.75, 394.25. So my new sale price is 415 minus my discount, 394.25. Okay. I could have gotten that sale price in 1 step, right? Instead of, I'm going to start with my 415, and to take 5% away, right? If you start with the concept that you're going to pay 100%, and you take 5% away from 100%, what do you get? 95%. So when something's on sale for 5% off, that means you're paying 95% of the price. So you take your 415, you multiply by 0.95, and that should give you your 394.25 in 1 step. Yes, and we got to add the tax. Yeah, we haven't factored in the tax yet. So I have to take that 394.25, increase it by 6.75%. So I'm going to take my total is going to be 394.25 and increase it by 6.75%. So what should I multiply by? 1.0675. Okay, so who has it done? Anybody? 420.86. Okay, so this is my out of pocket. That's what I have to pay when I check out from Hamiltonian circuits. So that's going to be a better buy than optimal buy, right? Better price. Even though the advertised price is higher, if I have my 5% off coupon, get a better deal. Coupon? Coupon? Okay. Anyways, so for our last option, we have the online. So this is like if you went on Amazon or eBay or something, and you found one for sale for $441 that includes shipping, right? There's no sales tax, so we don't have to worry about sales tax. But we can get this. So 441 is clearly higher than either of my other two options, so I'm not going to pay that, right? But if I can get someone to pick it up for me so I don't have to pay shipping, I wonder how much it would be. So how can I figure out what this was before I added 5% shipping? Yeah, you think that it might be, but that's not the case. Okay, so if I take, let's see what happens. If I take 95%, right, reduce 441 by 5%. So I'm going to take 95% of 441. So that's like saying, oh, we increased it by 5%, so to get that 5% off, just decrease it by 5%. So what do you get when you do this? 418.95. Okay, so let's check our work. If you increase 418.95 by 5%, does it get you back to 441? So I take my 418.95. If I want to increase it by 5%, what do I multiply by? 1.05. Let's see what that gives me. 418.95 times 1.05 is not 441, right? This is 439 and 80, 90 if I round, right? Which is not $441. So it can't be that the real price is $418.95, because if you increase $418.95 by 5% for shipping, you don't get $441. So the question is, what number should I put here so that when you multiply by 1.05, you get $441? So this number's wrong, right? It can't be this, because whatever number is here, when you multiply by 1.05, we're supposed to get 441. Take whatever the base price is, increase it by 5%, you should get 441. So I've got something, and I want to multiply it by 1.05 and get $441. How could I figure out what this something is? Divide both sides by 1.05. I could let this something be x, that's because that's what I don't know. Use a little bit of algebra from a previous class. Divide both sides by 1.05. And we get x is $420. That's the price before shipping. So to increase something by 1.05%, or by 5%, you multiply by 1.05. So to decrease, why didn't it work? That's a really good question. Let's start with something that's $100. $100, right? Base price. If you increase this price by 5% for whatever reason, increase by 5%, this is going to become $105, right? 5% increase. Now, if you take $105 and decrease it by 5%, it doesn't get you back to $100 because 5% of 105 is different than 5% of 100. Right. So to decrease, to go back, right? $105, if you decrease by 5%, $94.50. No, because 10% would be $10.50, so 5% would be $5.25. So $94.75, not $100, right? So if you do a 5% increase followed by a 5% decrease, they don't undo each other because you're taking 5% of a different amount in both of those problems. So this is like, people can really try to mess with you with percentages. Like guys, listen, we gotta do 5% pay cuts this year. But don't worry, we'll give you a 5% raise next year. Not going to get you back to where you started, right? Because 5% of a big number, like what you're making now, is bigger than 5% of the small number that they're going to give you an increase by. So 5% increase, 5% decrease followed by 5% increase doesn't get you back to where you started. So this is a really big point of confusion with percentages. It all depends on what your baseline is. What number are you taking a percentage of? So what's my best deal? Should I do the $420? Yeah. So Hamiltonian circuits is $420.86 versus $420 even. So I guess if you want to save your 86 cents, you can send your friend on a hunt for this iPod, or you could save her the trouble and pay 86 cents, right? All right, so these are some formulas for percent increase and decrease. You don't really need to memorize them because we just talked about them. If you start with a quantity and you want to increase by X percent, you multiply by 1 plus that thing is a decimal, right? And if you start with a quantity and you want to decrease by X percent, you start with 1 for 100% and subtract that percentage that you want to decrease by. So when we decreased by 5%, we multiplied by 0.95, right? So if I want to do example 5%, to increase by 5%, you would multiply by 1.05. To decrease by 5%, you'd multiply by 0.95. You can use these same formulas to solve for X, what the percent increase or decrease is, or Q, your initial quantity. So we solved in this last problem over here, we solved for Q, the initial quantity. But again, you don't need to have these formulas because, you know, we just used these formulas in 3 problems without having ever written them down. So, all right, so here's another problem that involves percentages. On a particular day, the Dow Jones closed at 12,875. The next day, it closed at 13,029.50. What percent did it increase by? Right, so my base quantity is 12,875. I'm going to increase it by some percentage, right? I don't know what. Multiply by 1 point something, right? To increase by some percent. And I'm going to land at $13,029.50. So the question is, what is this number? What did I multiply by? How do I figure it out? Divide, yeah. So this is the thing I don't know, right? So I divide both sides by 12,875. And I get X is 13,029.5 divided by 12,875, and I get 1.012. So is that my answer? Is that my percent increase, 1.012%? What does that number represent? The percentage plus 100%, right? The 1 represents 100%, and this is the decimal, right? So this represents, if I move the decimal 2 to the right, 101.2%, which is how much more than 100%? 1.2%, which is a 1.2% increase. So you could either say it's 101.2% of what it was, right? Which represents a 1.2% increase above what it was. Right? Because the 100% we already had. We started with 100%. Now we have 101.2%. So that means we gained or increased by 1.2%. All right, you try this one. On the third day, right? So this is day 1, 12,875. This is day 2, right? 13,029.50. Here's day 3. The Dow closes at 12,508.32. What is the percent decrease from the previous day? So what is the percent change from this amount? Okay, so first approach I'm going to use is sort of the one that I'm using or advocating, because you always set it up the same way. Okay, so now I have I'm starting with the 13,000 number, right? And I'm decreasing by some percentage, and I'm landing at 12,508. So I'm saying, okay, I'm starting with 13,029.5. I got to multiply by something to create a percent decrease. I know that this something is going to be bigger than or less than 1. Less than. To create a percent decrease, this thing has got to be less than 100%. And that should give me 12,508.32. Okay, so this is the most common approach that I saw, probably because it's the one I used in the previous example, but I'll go over some of the other ones also, because they might feel more intuitive to you. So this thing that I don't know, we'll call it X, and that's how I'm going to figure out my percent decrease. So I'm starting with 13,000, I got to multiply by something and get 12,500. So I'm going to divide both sides by my 13,000. And we get X is 0.96. So 0.96 represents 96%, right? So that means that I took 96% of 13,000 to get the 12,500, which means what percent did I decrease by? 4%. So this represents 96%, right? Which represents a 4% decrease. Right? 96% means we lost 4% from our original 100. All right, so I'm just going to go to another slide so I can show some of the other approaches that people used. Oh, sorry. Oh, okay, we'll go over that one in a minute. All right, so another formula that some people have been introduced to when dealing with percent change is to say, well, percent change is equal to the amount of change, right, just by doing a subtraction problem, how much it changed, compared to the original amount. And this formula is exactly equivalent to what we're doing, but it gives you the percent change as the answer. So amount of change, how can I figure out how much the Dow Jones changed? You subtract them. So I'm going to do that 13,000 number So what was it? 13,029.5 minus 12,508 point something. What was the decimal? 32. So my amount of change is 521.18 compared to my original amount, which was 13,029.5. Right, that's my original amount that I started with. So I divide by 13,029.5 and I get 0.04, which is 4%. And we know it's a decrease because the numbers got smaller, right? 4% decrease. So you can use, if you're familiar with this way of calculating percent change, you can use that. That's fine. You don't have to use the algebra method that I have been showing you. Oh, and then let's see, there was one more that was similar to this. Percent is just something over 100, right? So Brianne, I think, wrote, instead of writing percent here, she wrote what over 100 and solved for x and got 4. You solve this, you get x equals 4. So either way, whatever feels most intuitive to you, go with that. Okay, for number 8, percent decreases are often used incorrectly, mostly on purpose, but often in ignorance, right? In an effort to exaggerate or mislead. So for example, the police chief of Happyville reports that crime decreased by 200% in 1 year. He came up with this number based on reported crimes decreasing from 450 to 150. That's a big decrease. Okay. Is it a 200% decrease? Can you decrease by 200%? What's the most you can decrease by? 100%. The most, if you have some baseline, you know what crime used to be. If crime was gone, if we went from 450 to 0, that would be a decrease of 100%. 100% of crimes went away. Decreasing by 200% doesn't mean any, it's like a meaningless statement. You can't do that. Right. You would have to have 450 people doing random acts of kindness or something. Yeah. 100% decrease would be to 0, and then if you decreased another 100%, I guess negative crime is doing nice things. Yeah. Okay. So do you think he can get away with saying a 200% decrease? No, it doesn't mean anything. What's the real percent decrease? 67. How'd you get it? Okay, so we did 450 times what percent decrease gives you 150 remaining crimes. Divide both sides by 450. So we get x is 0.33, right? Which is 33%, right? Right. And this represents how much crime we still have. 33% of the 100% remains. So this is 33% remains, right? 150 is 33% to 450, which means we had a 67% decrease. It's still good. Yeah, it's not 200% though. 200% sounds more impressive, right? So let's do it the other way too. Let's do percent change, because that can be a little bit confusing when you get 33% and you have to remember to subtract it from 100. So if we do the percent change is equal to amount of change divided by the original amount, right? So we're always comparing to the amount we started with. So we went from 450 to 150, so that's 300, a decrease of 300 crimes, compared to the original amount of 450. That's 0.67 or 67% decrease. How did he get the 200%? How? Yeah, it went down by 300. He extrapolated from the 300 to get a 200%. 300 is 200% of 150. He used the wrong number as the baseline, right? He, instead of comparing to the original amount, right? He took the amount of change 300 and divided by the new 150, which is actually a very common mistake people use when they're calculating percentages. So so the mistake came by doing 300 divided by 150 instead of 450. So instead of comparing to the baseline, the original amount, he's comparing to the new amount. This gives you 2 or 200%. Right? This is wrong. So it could be a deliberate way to use percentages to make him look good. Could be a legitimate mistake because people are not that good at using percentages. All right, so an important part of being a smart shopper is being able to understand how markups and markdowns work. So I want you to work in your groups for a little bit on this toy store problem. So most groups started by subtracting the percentages, right? So we went up by 80%, right? And then we went down by 40%, and then down by another 25%, and that left us with 15%, right? Wrong? What's it come out to? Okay. But this is, in fact, wrong, right? You can't add and subtract the percentages like that. And the reason is the same reason that you can't, that an increase by 5% followed by a decrease of 5% doesn't get you back to where you started. Because what you're taking a percentage of changes, right? The amount that you're taking 80% of is a different number than what you're taking 40% off of, right? Is a different number than what you're taking 25% off of. So what I had most people do, I suggested, pick a price to start with. So an easy baseline is $100, right? So let's say that the wholesale price to the store is $100. Right? Then I'm going to do all these percent changes and see how much they end up selling this $100 item for. All right, so if the toy store marks $100 up by 80%, so I'm starting with $100, what do I multiply by to increase by 80%? 1.8, because 1 for keep 100% of it, plus 80% more, 0.8. So that comes out to $180. All right, then we have $180. That's what we're selling it for at, the peak of Christmas shopping season. $180, that's how much they're selling it for. Now we're going to take it off. After Christmas goes by, we reduce it by 40%. What do you multiply 180 by to bring it down by 40%? That would be for 4%. 0.6. If you're throwing 40% away, right? You get to reduce it by 40%. That means that you have to pay 60% of the original cost. So if I multiply 180 by 0.6, you get 108. So it's now on sale for $108, right? And then after a while, the few unsold toys go on the clearance rack for an additional 25% off, right? So finally, we have our $108, and it's going to go on sale for 25% off. So if it's 25% off, what percentage are you paying? 0.75, right? So I can multiply 108 by 0.75, and that comes out to $81. So this is the final price that they sell it for. What did they buy it for? $100. So are they making money or losing money? They're losing money on those final sales. What percentage are they losing? 19%. This represents a 19% loss. Because it represents a loss of $19, right? $100 to $81 is $19 loss. And it's 19%. Why? Why did $19 become 19%? Because $19 of my original $100 represents 19%. So that's a 19% loss. Okay, so the reason we spent some time here on percentages is because we're going to use them for a really important concept used in the business world and everyday life, right? Is the fact that money has a present value and a future value. So money is worth a certain amount today, and it will be worth probably more or less, depending on how you invest it in the future. So if you invest P dollars today for a promise that someone's going to give you F dollars at some future date, like you say, okay, Allie, I'm going to lend you 10 bucks. And the reason I'm going to do it is not because you're my good friend, but because you promised to pay me some amount back in the future. That amount F has to be more than what I'm giving her. Otherwise, why would I do it, right? If I give her $10, depriving myself of $10 that I could use for, you know, lunch or whatever, I would only do that if she's going to give me more than $10 back someday, right? So if you're given the present value, how do you calculate future value and or vice versa? The most important part of the answer depends on interest rate. So interest is the return that a lender expects to as a reward for the use of his or her money. So I say, Allie, I'll give you 10 bucks, and you're going to give me $12 back a month from now. $2 is my reward for lending you the $10 that you need today. So the standard way to describe an interest rate is as a yearly rate called annual percentage rate, or APR. So simple interest is the first kind of interest that we're going to study. And in simple interest, only the original money invested or borrowed, called the principal, generates interest over time. This is different from compound interest, where the principal generates some interest, and then the principal plus interest generates more interest, and so on. So compound interest, interest earns interest. In simple interest, only the original amount earns interest. So simple interest formula is this formula. F is for future value. P is for present value or principal, right, initial amount. So P dollars is your initial amount invested. T stands for years, and little r is the APR represented as a decimal. So let's do one example before we run out of time here. On the day you were born, your parents purchased a $1,000 savings bond that pays 5% annual simple interest. So every year, you're going to make 5% of $1,000. What is the value of the bond on your 18th birthday? Okay. So the future value of this bond, just going to use this formula. So I'm going to write it down, 1 plus RT. So I'm going to put a little F sub 18 here to represent the future value 18 years from now. Okay, so my initial investment, my P or present value, is $1,000. 1 plus, what is the APR on this guy? 5%. And then as a decimal, that would be 0.05. So 0.05 times T, which in this case is 18 years. So when I do this out, I do my 0.05 times 18, add that to 1, and then multiply by 1,000. And I get $1,900. So this is 1,000 times 1.9, which is $1,900. So 18 years later, this $1,000 bond is now worth $1,900. All right, we'll stop there.